the first part of factoring we need to know, on those directions, first of all, the first thing on that sheet that you need to know is whether or not, it says something about it being prime. Tell her whether or not it's prime. Can I factor it at all? Well, you can tell if a polynomial or a quadratic is prime by using the discriminant. That's not one of the things on your sheet for the test Monday, but the discriminant is important. All right, we did the thing where the discriminant is greater than 0, less than 0, or equal to 0. But there's also another part we could say. If the discriminant is equal to something like 0, 4, it's a 4, it should be a 4, 9, 16, 25, 36, 49. What are all those numbers?
Perfect squares.
They're all perfect squares. If the discriminant is equal to a perfect square, then it can be factored.
Okay.
And the discriminant is equal to a perfect square, it'll be able to be factored in some form or fashion. If the discriminant is anything but a perfect square, then it's prime.
Now what's the discriminant?
B squared minus 4ac. That's the discriminant. If it's anything but a perfect square, then you're not going to be able to factor it. It's either going to be an irrational number or a complex number. Alright, so that's the first part. The majority of these are not prime. Alright, here's our first example that we want to do. And I want to explain you the way that I factor, and bear with me for a little bit while I explain it, because it'll be different than what you've seen in the past. The first thing you need to know how to do is that which one's A, which one's B, and which one's C. You need to be able to identify that. That's fairly simple. A is 6, B is 21, and C is what?
12.
Negative 12. I kind of overlap the 1 and 2. Because this is a minus 12, that means C is negative 12. The reason that is this plus sign in the formula, this is a plus C. So if I plug a positive number in there, it's still going to be plus. But if I plug a negative number in there, it's going to be minus C. So C is equal to negative 12. That's the same thing as saying plus negative 12. But we just write minus because it's easier. Alright, so what I need to do is I make a T-chart. Now, some of you might have seen an X before. It's the same thing as the X. Alright, I just use a T because that's what I've always used. But if it's an X, it's the same thing if you've seen the X somewhere else before. So what I need you to do is the first thing that we're going to put this in the upper left-hand corner, is we're going to put A times C in this upper left-hand corner. We're going to put A times C there. So we're going to multiply A and C together. So 6 times negative 12 is what?
Negative 72.
Negative 72. Because we all know our 12 multiplication tables.
Yeah. I rough on love that, yeah.
Alright. And then B is 21. So that's going to go in the bottom left-hand corner. And this chart's just more of a way to keep things organized. To try to look so you can see what you need to look at. And it's all right there nice and compact. Sometimes now when I'm factoring in a hurry, I don't really make the chart because I'm comfortable with what I'm looking for. But this chart is a good way to help us organize our thoughts, and then eventually you'll start doing it subconsciously in your head. So now what I need, these other two spots that I've got, I need two numbers that multiply to give me 72. And when I add them, or when I multiply them, they give me negative 72. And when I add them, they give me a positive 21. So notice I haven't said anything about the signs or, which ones, I got two parentheses, which one's negative, which one's positive. I'm not worried about any of that. I'm worried about two numbers that multiply to give me negative 72 and add to give me positive 21. Well, if you don't know your factors of 72, you can do your favorite thing in the world, which is a factor tree. Which I can do 9 and 8. Then 8 goes to 2, and 2, and 2, and 9 goes into 3.
3
and 3. And I need 21. Alright. When I add them together, I need it to be 21. But the thing is, one of these, this is a negative. Alright, so if I multiply two numbers together, in order for it to give me a negative, the signs are going to be what? One's going to be positive, one's going to be negative. So if I multiply 2 times 2 times 2 times 3 times 3, it'll give me 72. So I can mix and match these numbers in any way I want to give me something that gives me 21. If I multiply, I multiply 2 times 2 times 2, which is 8, times 3 is what? 24. I got 24 and 3. Can I add 24 and 3 and get 21? I can if I do what?
If you make the 3 negative 3.
If I make the 3 a negative. So 24 plus a negative 3 gives me a positive 21. And 24 times negative 3 gives me a negative 72. So that's our goal, is to be able to full out 2 binomials and get the polynomial at the top, the quadratic at the top. So once I found 24 and negative 3, that's the only time I really have to guess and check. Alright, anything. So from here on out, all I need to know is what A is. A is 6. So what I'm going to do is I'm going to make 2 fractions. And I use fractions because it's easier to understand the concept of simplifying fractions than it is the other way to do it, which is confusing. Most of the time you can simplify fractions. Alright, so we're going to simplify 24, or 6 over 24 and 6 over negative 3. We're going to simplify these. Alright, 6 goes into 24 4 times. 6 goes into 6 1 time. So I'm simplifying 6 over 24. And then I'm simplifying 6 over negative 3, which is that. Now that I've done that, I know what my parentheses are. Because remember, we always have to have an X. I don't have enough room here. So I'm going to write it over here. Alright, so I'm going to have 2 sets of parentheses. Alright, and it doesn't matter which fractions you put with which. But like this fraction is going to give me one set of parentheses. This fraction is going to give me the other set of parentheses. Alright, so I did this so I could figure out what my number in front of x needs to be. Alright, so this is going to give me 1x, and it's a positive 4, so one parentheses is going to be 1x plus 4. Because once I simplified this, I had a 1 on top, and it's a positive 4, so it's 1x plus 4. Alright, so that gives me the first parentheses. Then the second parentheses is going to be what? What do you think? 2x minus 1.
Oh, I get it now.
That we didn't pull out at the beginning. Alright, so I've got 6, 21, and 12. What's a number that I can divide all those by? 3. If I divide all those by 3, that's like I'm factoring out a 3. It's not showing up on it. It's like I'm factoring out a 3. So that's going to give me 2x squared. Alright, so I'm dividing each of those by 3. That's a terrible squared. Alright. 2x squared plus 7x minus 4. So, because I can divide each of these terms by 3, alright, so it's going to pull a 3 out. And lots of times on the ACT, they'll give you problems like this, right? And they would give you this answer choice right here. They would give you this answer choice, and it's not technically right because it's missing what? A 3. But if I put that 3 on the outside, now it's correct. Because it's a scalar multiple that I have to pull out. So really we could have pulled the 3 out at the beginning and just factored this right here if we wanted to. And that would change our signs over here. It would change our numbers over here. But our ultimate end goal would still give us this right here. So whether you pull the 3 out at the beginning or at the end, it doesn't matter. I'm just showing you, I wanted to do it that way because I do this like 90% of the time when I factor something. I'll factor it just the way it is with this right here. I'll simplify it down, and then I always fool the first term just to make sure that it works out. And I would do x times 2x, and it'd be 2x squared instead of 6x squared, and I'd be like, okay, well I need to go check to make sure if I can pull something out. If I couldn't pull something out up here, then I did something wrong, or it just couldn't be factored. But more than likely, once I simplify the fractions and I get this, and it's not the same as this front number, I can pull some number out of here. It'll always be some kind of number. I'll pull some number out to give me what I need at the bottom. Once my signs are right with the 24 and the negative 3, it automatically is going to give me the signs I need in my parentheses, as long as I carry the signs with me in the fractions. If I carry the signs with me in the fractions and then carry them over to the parentheses, my signs are going to be right. So the main thing is you need to know how to add, subtract, multiply positive and negative numbers. So we still got to make the chart. A times C is going to give me 60. And then B is 23. Then I need two numbers multiply to give me 60 and add to give me 23. And if you can't figure it out, you can do a factor tree. But what two numbers could give me 60 and multiply give me 20? 20 and 3. So after I've chosen the 20 and the 3, because those are the numbers I need, I'm going to make two fractions with a 10 on top. And then sometimes you'll see it without the x, sometimes you see it with the x. I just always put the x. Doesn't really matter. Alright, put 20 on bottom of one, 3 on bottom of the other, then simplify. 10 over 20 is the same as 1/2. And then I can't simplify 10 over 3. So my two parentheses, alright, is going to be 1x plus 2 and 10x plus 3. And then 1x times 10x is 10x squared. So we're on the right track. And you could completely fill that out if you wanted to see if you're right. But I've already done it, so I know that's right. Yeah, technically this doesn't factor the way I did it. This should be an x. Glad you pointed that out. Yeah. Yeah, they have to all be the same later. Otherwise, that wouldn't do anything. We're going to talk about that one. You can still factor that one, but there's a situation. I know. We're going to talk about if they had more than one letter. In that case, it wouldn't factor when it had more than one letter, but sometimes it will. We're going to talk about two very common situations where it will factor. So this one has actually 3 different letters in it, but it's a very common situation in factoring that we see a lot. So I need us to be familiar with it. I'm hoping by the time the end of this year, hopefully at least next year, that when you see something like this, that you automatically know what to do. What is the letter that I have in both terms?
P.
So just like I factored that 3 out earlier, I can factor that P out because it's in both terms.
Yeah.
So I got a P on the outside, and then I got M squared minus 81 x squared. Is anybody confused on what I did there? Now, it doesn't mean the P just disappears. Now, there's times where if I distribute the P back out, then it gives me what I had at the top. Now, what I have inside the parentheses is a very common problem that you'll see all the time when it comes to factoring. And it's on that sheet that I gave you for the stuff you must know called Monday. That formula that I gave you is in the very bottom right-hand corner, called a difference of squares. That's where this comes in. How I know that this is a difference of squares. Alright, when it comes to letters, alright, I need to be able to take in anything, I need to be able to take the square root of what's on the left of the minus sign and the square root of what's on the right of the minus sign. If I can do that, then it's a difference of squares, because difference means subtraction. So it's minus. I'm subtracting 2 squares. Alright, anytime it's a letter, because we simplified radicals, anytime it's a letter, if the power in the letter is even, so if it's 2, 4, 6, 8, 10, 12, then I can take the square root of it. the letter and the exponent. So I can take the square root of m squared because m is 2. If m was 8, I could take the square root of m to the 8th. It would be m to the 4th. But so I can take that. Then I got to check the numbers. Can I take the square root of 16? It's 4. Well, the square root of 81 is 9. Okay? So the difference of squares automatically gives me my two parentheses. And if you'll remember from the formula, one of them's plus and one of them's minus. Alright, so I need the first term, the square root of 16 we said was 4. Square root of m squared is what?
M.
Just m. And that's going to be the front term in both of these binomials. And then, so what's the other two? What's the other one two going to be? 9x and 9x. Right. So that's how you factor a difference of squares. But you haven't seen a ton of them at this point to where you just see that naturally and you're able to do it. Like I'm hoping that you'll be able to see it naturally, because that's really the only way to tell that you can factor that. Now if we're going backwards and we wanted to full this out, I could full it out and the middle two terms would cancel and I'd be left with this. But if I have two sets of parentheses and they're exactly the same, one's plus and one's minus, I don't have to do those two inside steps of FOIL. I can just multiply 4m times 4m, which gives me 16m squared. Then I can multiply 9x times 9x and get 81x squared and put the minus sign in the middle, because I know that's a difference of squares. That's why I want you to know both sides of that formula on the stuff you must know cold. Because
Algebra 1 to Algebra 2.
one thing, I do want to go back and talk about this, because those bottom 4 problems on your worksheet, like this is our second example, or our first example, I don't know which one. Anyway.
Yeah, we're first.
If we go back and the problem set is equal to 0, y'all had some of those on your worksheet?
Yeah.
It said solve this when it's equal to 0. Once I get my answer, all it wants you to do is factor. Once I factor, I'm going to take each parenthesis set individually and set it equal to 0. So I would have x plus 4, set it equal to 0, and 2x minus 1, set it equal to 0. I don't have to worry about this 3. I don't have to worry about setting it equal to 0, because it's just 3 is not equal to 0. So, if I were to put the 3 with one of these parentheses, I'd have to divide by 3, and then that's going to give me 0 divided by 3 is 0. So if it's a number, if you have a number on the outside, you don't have to worry about setting it equal to 0. You just got to set these two parentheses equal to 0. Okay? And then you solve those, and you're going to have two answers. When you solve a quadratic, you're going to have two answers. Even if you have to use quadratic formula, you're going to have two answers because of that plus or minus square root. That means you've got two answers. Okay. Same thing with this. If it was equal to 0, you'd set each of those parentheses. Each of those parentheses would be set equal to 0. You probably wouldn't have this one. You wouldn't have the other one set equal to 0 because it's got more than one letter in it. So you don't have to worry about that. Because you can't solve that because you've got 3 letters in there. If these were all the same letter, then yeah, you could. So is there any questions so far? This problem also has 2 letters in it, but we can still factor it. So one thing I need you to be able to see is this is actually a fairly common problem on the ACT as well. Is it'll give you something like this and it'll tell you to factor it. Alright. The thing you need to look for when there's more than one letter, see if you can pull that letter out. I can't pull a Y or an X out because all 3 terms would have to have one. This term doesn't have a Y, so I can't pull a Y out. This term doesn't have an X, so I can't pull an X out. So that doesn't work. So the next thing I need to look for, right? Does it have a certain look to it? Which this one does. I need to look for this. This is x squared. Whatever that letter is, it could be A, B, C, D. All that, it doesn't matter. All right. If it's squared, and the other letter's squared, and then they're in the middle together, then it can be factored. So if the first letter squared, second letter squared, middle letter squared, Well, I'll say it could be factored, but it'll be factored like the first two examples that we done. So really what we need to do is take away this letter at the end. So take away the y and write it down like the y's are just not there.
Okay.
So 4x squared, we're going to add the y back at the very end, but we don't need it right now. I want to factor it just like the y's are not there. So that's 4x squared minus 10x minus 6. If that can't be factored, then the top can't be factored. But right now, just by looking at the x's and the y's, we think that this can be factored because the x is squared, the y is squared, and they're together in the middle by their.
Can you factor that?
Yes, that's good. That's where my next step was going. I can divide all these by 2, so I can go ahead and pull out a 2. It's 2x squared minus 5x minus 3.
This is so difficult for me. I already had all this stuff down.
Well, you could have still kept going with it, and it would have worked out. You just had to add this 2 back at the end.
It's easier to do it at the beginning so you don't get into that.
That is true. But remember, when you simplify the fractions down, when I multiplied the two things together, I wouldn't have got 4x squared. So I would have known that I needed to do that. Should have. Alright, so from here, we can make our t-chart. Alright, so we're going to have negative 6 and negative 5. So what do I multiply together to give me negative 6 and add to give me negative 5?
3.
All right, let's do that. Negative 2 times negative 3. All right, negative 2 plus negative 3 does give me negative 5. But what's negative 2 times negative 3? Positive 6. Is that doesn't want to? That's not what I want.
It's negative 6 and positive.
Yes, negative 6 and positive 1. Because if negative 6 plus 1 is negative 5, and negative 6 times 1 is negative 6. Does everybody see why I picked those two numbers?
Yes.
Okay.
But could you do the other one?
The negative 2 and negative 3?
No.
No, that didn't work.
Oh, yeah.
Because it's positive. It gives you a positive 6. So now I can make my parentheses. And since I'm using this polynomial, I don't use the 4. I use the 2. So it's 2x and negative 6. 2x and 1. So I can simplify. That's 1. That's 3. I can't simplify the 2 and the 1 in the next one. So my parentheses are going to be 1x minus 3 and 2x plus 1. Alright, well, what am I missing?
The times 2.
Well, I'm missing the 2 out the front. And what else am I missing from the beginning?
Y's.
The y's. So I've got to add the y's back somewhere. Alright?
To the end of the
I'm going to put them...
negative 3 and
I'm going to put them here. And I'm going to write that so you can see it a
But
little
you
bit.
have one more Y though.
I'm going to explain it.
Yeah. You get
I'm going to put the y's back at the end. Alright? Because what would happen here is if I multiply this together, it's going to give me 2x squared. Alright? And if I multiply these other two together, it would be negative 3y squared. Which is really what I would have if I put the y's back into this problem here. I got the 2x squared, but I'd have the negative 3y. Now, when I take those y's away, I'm not like pulling that y out. I'm just ignoring them for a little while. I'm putting them back in. Here. But like if I full this out, so this would be my answer. Does anyone have any questions on this so far? There's one very similar to this on that worksheet. Yeah. The only other thing we're going to go over is just, it's not really factoring. It's just to give you a quick reminder because you may not have seen it in a while.
I don't have anything to do.
Oh, look, it's there.
I don't like negativities.
I don't like anything but square.
Okay, so if I have a power on the outside of something like this, which there is some of those on your problem, there's distributive properties of addition and there's distributive properties of multiplication. So I'm going to distribute this power to everything inside the parentheses. So I'm going to distribute to the 4, the x, the y, and the c. And if I just distribute the power of 3 to the 4, I've really got there's really an exponent of 1 there, right?
Yes.
4 to the first. And then if I raise an exponent to a power to a power, I multiply the exponent. So 3 times 1, so I'd have 4 to the third here. Then I've got x to the negative third raised to the third power. So that's negative 9. I have y to the fourth raised to the third power, so which is 12th. Y to the 12th. And then c to the 6th. Alright, and then this other one doesn't really have, there's an exponent of 1 there, but it doesn't really have a power, so I'm just going to rewrite it the way it is.
Put your parentheses.
Because it's in parentheses. Because I'm multiplying these two things together is why it's in parentheses.
But why would you not still keep it in parentheses?
Because now it's all multiplication, the same thing. I'm not distributing it out because it's multiplication. And it doesn't have any addition in it. So this is all multiplication. All in between here we have multiplication. So since it's all multiplication in between there, I don't really need the parentheses because it's all one big multiplication. I'm just multiplying all that stuff together. So I don't need the parentheses there. Now if there's a plus sign somewhere, then that's when I'd have to fool or something like that. But since it's all multiplication, I can just drop the parentheses from there. I just had to distribute that 3 first before I could do that with the other problem. So now we just got to use our rules for multiplying.
Like, can we combine?
Yeah, we're going to combine stuff. Yeah, that's what we're going to do next. So I can combine the numbers together. Right, 4 to the third is what from your sheet? 64. That's on your test Monday. 4 to the third, 64 times 3, 192.
Good job, guys.
All right. Then I can do the x's. When I multiply x to the 9th times x to the 5th, what do I do with the exponents?
You
Add them, which, yeah, it's really... So it's going to be negative 4. Then the y to the 12th.
20.
All right, it's going to give me 20.
10.
And then 10.
Yay.
Not quite done yet, because what do I have to do with a negative exponent? Do what?
Put it over
I
one.
think somebody said something.
Put it up.
Make a fraction and put it on the bottom. So I have to... Because really it would be 1 over x to the 4th. But all that means is I've got a big line of all this stuff, so I'm going to put it on the bottom. So there's my answer.
Yay.